first thing I want to talk about, of course, is this is a review, obviously. And I want you to understand something here. This whole chapter has been about simplifying. And most of that you've seen so far, when I say simplified, this is how it's written. You don't see an equal signs. I'm not asking you to solve. See, solving and simplifying, there are two different things. When I ask you to solve, you see an equation. That means there is something on the left-hand side of the equal sign, and there is something on the right-hand side of the equal sign. That's called solving, because there will be a specific variable that I want you to solve for. But when I ask you to simplify, it simply means make it look simpler. Okay? And with multiple terms, a top like polynomial, we have a chart for that, don't we? The chart, like the simplifying chart, that allows us to look at, oh, if it's 2 terms or 3 or 4, we always look at the orderness. We always look at, is there a GCF that we can take out? If it's 2 terms, is it a dots? If it's 3 terms, is it a PST? And so on. And if it's not a PST, can we do an X box on it? And if, of course, it's 4 term, can we just do a box on it? So that still applies here for this chapter, and I really want you to see it. And here, for example, like this first problem right here, I asked you once again. I did not ask you to solve. I asked you to simplify. Meaning, make it simpler. What you see here is 3 terms, right? That's a trinomial. And, we certainly kind of quickly go through our first 2 questions and we realize that everything's already in order and there's no GCF to take out. We can go right into, is it PST? Apparently not, because the first and the last numbers are not perfect square numbers. And what are perfect square numbers again? 1. What's the next number?
3.
Perfect square numbers?
No.
4, next. 9, 16, 25, and basically you just take a whole number and multiply by itself, you get yourself a perfect square number. Okay? So every time you give me a perfect square number, you always ask that question. Wait, did I take the whole number and multiply to get it? Okay? But anyway, none of them are perfect square numbers, and so we know we can bypass PST. It goes straight into what now? It's a trinomial. X box it. And sometimes for a trinomial we can bypass the box because what? There's a 1 in front, but obviously for these 2, unfortunately, they have 6 in front. So that means we cannot bypass it. So let's start from the top. Here we go. First one, I'm going to go and show you how to do that. And again, it's a trinomial, so I'm going to start setting up an x first. What do we put on top?
Negative 18.
Negative 18, bottom. Negative 7. What times what is negative 18?
9 and 2.
9 and 2, okay. I like the fact that you give me 2 positive numbers first. And then from there you say, wait, if I take 9 times 2, do I get negative 18?
Yeah.
No, so that means one of the 2 numbers has to be a negative because my sum has to be a negative as well. Which number has to be it?
9.
Yeah, 9. So I got that, and now I can certainly do a what on it? Box on it, right? I already did the x, so here's the box. Do I put it inside or outside? Inside, right? Because we want to factor out.
Yeah.
You don't want to say factor in, right? We're factoring it outside. So that means we have to start from inside first. Okay, so here we know we have to write it into 4 terms, but obviously this is going to be replaced by the 2 numbers that we found here. Okay, so this is how you write it. 6x squared, negative 9, what? X. 2x, and negative 3. Okay, so I hope this serves as a good review for you on those of you who are kind of a bit shaky on an Xbox. So here it is. What can you take outside? 3x. And here?
1.
Just a 1, right. And we can just go ahead and multiply here. 2x and negative 3. Check here. Check. Everything looks good. So we got our box covered. So I'm going to go ahead and do the same thing for the bottom. Organization is really helpful for this chapter, or the last, obviously. If you stay organized throughout the process, it's a lot easier for you to go back on. I really encourage you to have like multiple colored pencil or pens or something, so you can circle. Oh, this is the pink part. This is the whatever green part, And here's the x. Negative 6 on top. I'm going to speed this through because it's exactly the same thing like the other one, right? So I'm just going to go and do it. What times what is negative 6 added to negative 1? 3 and 2, and which one's the negative? The 3. Okay, very good. And I do the box on this thing, and I fill in 6x squared minus 3x, 2x, and negative 1. Feel free to stop me if you feel like, oh, I didn't get that. Okay. 3x here and just 1, so 2x and negative 1. Checked. Everything looks good. So we got it. So we got the X box set up. Now we just go ahead and write out our terms. write our factors basically. So if we write our factors, this is what you see. On the top, I have 2x minus 3. I got 3x plus 1. That's on the top. On the bottom, I have 2x minus 1, and I have 3x plus 1. Now before you say, yeah, let's start canceling the factors out, please read the direction. I asked you to find the excluded value, right? So before you start canceling out anything, look at the excluded value. Strictly, where are we looking at to find excluded values? What is it? Bottom. Just the bottom. So here it is again. What do we need to set the bottom to find excluded value? 0. So now if I set this to 0, I have two cases, and I want people to realize that this is what they have to do next. You are setting each factor to 0 and solve for it. So 2x minus 1 equals 0. You add the 1 over. That's 2x equals to 1. So divided by 2 both sides. X is 1/2. And I can kind of quickly do this in my head if I can. Minus 1 over, right? Divided by 3, so that's negative 1 over 3. So the other answer is negative 1/3. So these right here, guys, are called excluded values. EV for short. Okay? So I found my excluded values. Now I can actually go back and see if I can actually cancel anything out to make it simple. What can I cancel? 3x plus 1. And why can I actually cancel it out vertically like that? Because they're all linked up by multiplications. Okay? So my simplified answer now is simply 2x minus 3 over 2x minus 1. And there you have it. This is your simplified form. This is your excluded values. But notice I have to find my excluded values first before I simplify to get my final answers. Does it make sense? And there it is for the first problem. This is to start off, and notice that the rest is pretty much very similar. Okay? Any question on one? And this information, of course, will be online for you, too. Okay? Just in case you miss anything, I'll be there for you. Okay, take a look at number 2. Here it is. Okay, so right off the bat, what do you see? A lot of what? What do you think you're going to be doing here for this problem? X boxes. Very good. A lot of X boxes. Huh? Okay, so like if you have like 4 different colors, this is a good time to use them. I'm going to say, oh yeah, I'm going to go and do this one with this. I'm going to do this one with this. Here's the other one. And here's the other one. But
That many?
if you have space, just go and pull each one out and work in that space so you don't get all mixed up. So let's start with the first one, the purple. Okay.
30 on, negative 30 on top.
Oh, good. So we have to do the X box on that, right? So negative 30 on top.
1 on the bottom.
1 on the bottom.
Yeah.
Negative 1. Don't forget the signs here. Stays with the number. So what times what is negative 30 added to negative 1? Negative 6 and 5. That works out for me here. And let's do a box on that too while we're at it. So 2b squared, negative 6b, 5b, and negative 15. Let's factor it out. What can you take out?
2.
2b, right? Don't forget also the variable. What about the 5 and the negative 15?
5.
The 5. So let's go ahead and cross multiply here. 2b times b is 2b squared and negative 3, right? So everything checked out just fine for that one. And we can go ahead and move ahead with the purple. I mean the pink. The pink here, what do we put on top? Negative 18. And 7 on the bottom. What do we have here? What times what's negative 18 added to 7? 9 and 2, and then of course the negative 2, right? And we repeat the same process again. Here's the box. 6b squared, 9b, negative 2b, negative 3, and we factor it out. What can we take outside?
3b.
3b. And here, what can I take outside?
Negative 1.
Good. First negative has to be taken out. Negative 1. And this is 2b and 3, right? We're good. Move on to the green. We got the x set up for the green. It's negative 6 over 5. And what times 1 is negative 6 added to 5?
3 1.
3 and 2. 3 and 2 will add up to 5, but won't give you a negative 6 when you multiply. 6 and 1, which one is the negative?
Negative 1.
Very good. And there you have it. So be careful. Sometimes one combination doesn't work out. Try another one. You got yourself 3b squared 6b, negative 1b, and negative 2. What can I take out here?
Shouldn't it just be negative b?
Negative 1.
Since it's just 1.
Yeah, I know. I can negative 1b or negative b. Doesn't matter. Same thing. And here, what can you take out? Negative 1. Okay. And so let's go ahead and cross multiply here. You got
B,
b and
2.
2, right? Okay. So it looks good for the green. Let's do the blue. X that is negative 6 over negative 1. What times 1 is negative 6 added to negative 1? 2, 3? Okay.
Yeah.
2 and 3. Which one's the negative?
3.
Okay, good. And look. The blue, do we need a box for it?
No.
No. So I hope now you see why. Okay, so now that I have everything already set up, we can put the whole thing together, starting with the purple again. B minus 3, 2b plus 5. Okay, and the bottom, I have 2b plus 3, 3b minus 1. Everything is multiplied by b plus 2, 3b minus 1, over b plus 2, b minus 3. Look at that. Do I have everything linked by multiplications? Indeed. So now we can actually cancel. I just read the direction one last time, see if I need to find anything. No, I'm good. So let's take a look. Do we have anything in common? Almost everything.
There's b and 2.
3 and
B plus 2.
b plus 2 and b plus 2 gone. Next.
3b minus 1.
3b minus 1 gone.
B minus 1.
B minus 3.
b minus
Left
3
top,
gone.
bottom right.
So is that it? That's it. So that means our final answer, guys, is
2b plus 5.
2b plus 5
2b
over
plus 3.
2b plus 3. And this is our simplified form. That's it.
Dude, that's what we got.
So staying organized really helps, huh? Notice how I hope that when you watch this again at home and see different colors associated to each problem, that makes more sense for you. Okay. Any question on that? Okay. All right. Moving on. All right.
Okay.
Okay. Good, right?
Got that.
All right. So, yes, you would definitely see a lot of factoring problems for sure. So I want you to practice this. Look at this. Try to take up. Yes.
We don't have to find the absolute value.
Well, I didn't ask you for it. But if you do, then yeah, you certainly have to, right?
Okay.
But
He didn't ask.
Stop making stuff as, stop making stuff complicated.
okay, moving on. And look, a simple problem like the other one. But this time, since I asked you to divide, and we know that when we divide fractions, then what do we need to do?
Reciprocal.
Reciprocal. Very good. So, if I were you, I would have to rewrite the problem first before I do anything else. So let's rewrite. I got n squared minus 5n plus 6 over w squared plus 9w plus 14 times. You see it? So now,
plus 7.
I have w plus 7 going on top, and the bottom,
Over 2
2 minus n.
and 3 minus n.
There it is. Okay, so set up the problem again. Just make sure that, hey, yeah, I have now a multiplication problem for me to work on. And I look at this and I realize that, hey, I can do just x. Why?
Not many colors.
Because the first term is it's a 1.
1.
And always check for ordinates, of course. Look, 2, 1, none. 2, 1, none. You see it? It has to be in order for you to work on it. Don't always assume that because it's 3 term, I can just do an x box on it. No, no, no. You got to check for the power. Is it in order? It has to have some kind of order on it, okay, for you to work on it. So let's take a look at the
6 on
first
top,
part.
Negative 5.
6 on top, negative 5. What times what is 6 added to negative?
3, 2. No.
3 and 2.
Negative 3.
Negative 3, negative 2. Very good. They're both negative. That will work.
Okay.
What up at the bottom?
Like 14 and 9.
14 and 9.
2, 7.
2 and 7.
Hey.
That works just fine. Okay, so let's write it out. On the top I have n minus 3, n minus 2. On the bottom I have w plus 7, w plus 2. Now on the other side, watch what happened. I have w plus 7 on top, right? But I realized something, that hey, I have 2 minus n here, and on the top I have n minus 2. They're exactly opposite of each other.
Put squared.
Didn't we have a way?
Yeah,
We
make the negative 1 thingy.
Okay, so what that means, you have to take the negative 1 outside.
Yeah, take the, yeah,
So watch what happened.
One outside thing.
So to write it as n minus 2, you have to take out a negative 1 outside.
Make it a pot.
See it? Now that will work.
Uh-huh.
And I also realized that this is all written in opposite as well. The terms are opposite each other, so I can do the same trick. I put a -1 outside, and I can rewrite it as n minus 3. So be very careful when you see terms that are opposite each other. So, but then the good thing is, what is -1 times -1?
Positive one.
So basically, they're gone, right? So I can just look at the whole problem and say that, oh yeah, I have some
So what's the
several.
point of putting the -1 if you're just gonna
Be-
cross it out?
You get to switch it.
Okay, listen, Centino. This is 2 minus n.
Yeah.
It's not the same thing as n minus 2, is it? Because they're opposite each other.
Yeah.
For us to write it as n minus 2, we have to take out a -1 out of it. We'll factor it out anyway.
Yeah.
And notice, if I multiply back in, don't have the same thing.
Yeah, yeah.
But it's just a way to rewrite it. But because we have double negative, it'll kind of go away on its own. But if this is just one term, then this will be a negative problem. See it?
Yeah.
Same. All right. Look at this. W plus 7 gone. Anything else?
No.
N minus
N minus
N minus 2, N minus 3. What's left over? 1 on top. W plus 2 in the bottom.
Got
That's it.
that.
Done.
Got that.
Lying.
Okay. Moving on.
Wait.
Yes.
Oh.
Okay. So the problem can be very complicated at first, but if you simplify gradually, it'll make it easier for you to do. Okay. Got it? Okay. Take one before. Ooh, look at this one right here. What's the trick for this?
Divide. Hey.
What's the trick for this kind of problem? You have a whole bunch of terms on top over.
Paying attention.
Huh? What's that?
This is Jennifer's handwriting.
See? Shh. Look. Is it true? I gave you this problem before. Is it true that I have a problem like this? Over the same denominator? That it's okay for me to write it like this? And it means the same thing?
Oh.
Did I give you that approach before?
Yeah.
Yeah.
So, why is it that I want to break it apart? Because if I break it apart, it makes it a lot easier for us to simplify. So watch what happened. We got 15a cubed b squared over 10a squared b squared. What? Minus.
What? Holy cow.
Stay focused, please.
Okay.
Thank you. All right. Look at that. I have everything separated. And now I can look at each fraction and try to simplify. Because technically now, it is a monomial, right? All linked up by multiplications. And I see if I can actually simplify anything. 15 over 10?
2, 3.
By 5. So that means the top now becomes 3 and the bottom is 2. A cubed over a squared.
A.
A where?
Top.
Top. And of course b squared cancel. We're done with b. Move on to the next thing. 5, 10.
5. This is 1.
1 on top. 2 on bottom. A squared cancel, right?
Cancel.
And the b
on
where's
bottom.
B bottom. Go on. Next one, 20 over 10.
10. 10.
2 on top, right? Basically, if you divide by 10 both. Okay. A and a squared. A cubed. This is a and this is a squared.
A on the bottom.
A is on the bottom.
B.
And
B2 on top.
b squared on top.
Square on top.
And that's it. Done. That's it. So this is a trick for it, and then hopefully when you see this problem again, you know what to do. Okay? We only try to simplify as much as we can. And if you have like a polynomial divided by a monomial in this case, we just break them apart. Okay? And simplify each fraction. Okay. Moving on.
Wait.
I'm getting those.
Our master, whatever, expert didn't do all this.
That's one.
What?
Okay. Look at this right here. So this is the problem I wanted to share with you about. And yeah.
It's fine.
Oh, good. First of all, you're right. The first thing is the prime cannot factor or anything like that. If we cannot factor, then what do we do? Long division. But please understand here. I'm going to show you this carefully again. So write this down carefully. If I'm going to be doing a long division for this problem, first thing you got to realize is the bottom goes out, right? The inside, however, will be made up of this polynomial, but I realized one important thing. What is missing?
The x squared.
The second square. The square term is missing. So whatever it is that you're missing, you have to fill it in with a 0 term for that. And now, if I rewrite the entire problem, it's no longer a trinomial. It is a
Binomial.
it's a polynomial of 4 terms. Polynomial of 4 terms. But if you look and check the degree again, 3, 2, 1, none. It is in order, and everything is accounted for. You see it? The power, everything's there. So let's start from the very top. Remember when we do our long division, even though we have 2 terms outside, we only start comparing or use the first term only. And then we say 3 here. 3 times what is 9?
3.
Okay? X times what is x cubed?
X squared.
X squared. And that's how we got our first answer, right? And what do we do with that? Not yet. What do we do with this? Distribute. Because we don't have just 3x, we have a -2 as well. So we have to distribute that to both terms outside to get this. 9x cubed minus 6x squared. And once we have the inside, what do we do each time? What do we do now? Subtract. So I have to manually put in the subtraction sign. I encourage you to do so, because if you don't put in the subtraction sign, you will not see this. What is a negative? Negative here will become positive. You see it? That's very important. You got to put in yourself. And now when you do this, this is, 9 will cancel, but this becomes 6x squared, right?
Yes.
Then you move down to negative 16x. And you start this whole process all over again. So 3x times what is 6x squared?
2x.
2x. So that's positive, so I put positive, and I follow the same process. Distribute again. This becomes 6x squared minus 4x, right?
Yes.
And watch what happens. Put the subtraction sign, don't forget, because this will get canceled, but these two negative will become
Positive.
positive again. Negative 14x plus 4x.
22.
Negative 16x plus 4x.
Oh, negative 12x.
Negative 12x.
Negative 12.
You bring down the negative 5. And we start this process, what? Again, right? 3x times what is negative 12x? Negative 4. And there you have it. You distribute negative 4 to both terms, and you have negative 12x and positive 8. And here we can subtract. This is gone, of course.
Oh snap, we're dividing.
What is negative 5 minus 8?
Negative 3.
What's negative 5 minus 8? Negative 5 minus 8.
Oh,
Negative 3.
See? If you can't see it, write it out.
Negative 3.
Okay, so what's negative 5 minus 8? It's not
Oh,
negative 5 plus 8.
okay.
Or, it's negative 5 minus 8.
Okay.
So negative 13,
Negative 13.
right? This is our remainder. This is how we write our remainder, and I want you to make sure you see this. You just basically attach it to the end of your answer. So here it is, over divisor, 3x minus 2. Adding or subtracting, well, if you add minus, it's still going to turn back to a minus. Is that true? Because look, if it's going to be, if you know you're going to be subtracting, a plus and minus will turn back into a minus sign. So that's why I just combine and put them as one sign. Or if you don't feel confident with that, you certainly do this. It's fine. But you know this will turn to a minus. Okay? Alright. But that's it. That's how long division works. And I really want you to take a look at it. Okay? We're good? Okay. Moving on to number 6. We're halfway through, so I need your attention on this next problem. Okay, so we're shifting gears, guys. Instead of multiplying and dividing, we're now adding and subtracting. Every time we add and subtract a fraction, what do we have to find? Yeah, LCD, least common denominator, right? So here, we know this is over a 1, and we know that p minus 4 is already simplified in fact completely, so we have nothing to worry about that. What is the LCD here for both?
P minus 4.
P minus 4. So what I'm going to do next is I set up my new fraction with a new denominator of p minus 4. And I start comparing. What do I need to multiply 1 by to make it p minus 4?
P minus 4.
P minus 4. So whatever I do to the bottom, I have to repeat that to the top. So now the p plus 2 will be multiplied by the p minus 4. Here, this is already the same, so do I need to alter the top? No. So the top simply is going to remain the same, right? But here's another thing though. We know we're trying to combine these together, right? But for us to combine these, we have to break the p out of the parentheses. This is multiplication, so how do we break it out of the parentheses? Box it, yeah. Reasons? If it's just like a one term, you just distribute to break it out. But this is a 2 by 2, we gotta box it. So it's a 2 by 2 box, and here it is. P plus 2, P minus 4. What do you have inside?
P squared.
P squared, 2P. Oh, come on.
It's not that funny.
Negative 4P and negative 8, right? To combine like terms. Do you see the difference here?
Quiet.
The other ones, thank you, but the other ones, we are factoring outside, so we start from the inside. But here, when we multiply in, so we start from the outside and go in. Okay, so when we combine like terms here, what we see is P squared minus 2P minus 8. Let's cross it over, add it over to, add P plus 1, everything over what? P minus 4.
P squared.
Vanessa, you have questions?
P minus 8.
Okay. Do we see any like terms here? On the top? So, because we want to combine them, right? Do you see any like terms?
No.
The P,
1 P.
and negative 8 and 1. Okay, let's put them all together. P squared. What is negative 2P?
Minus 3P.
What is negative 2 plus 1?
-1.
See? This is negative 2P plus 1P, right?
Oh, yeah.
It's not like 2P plus
So
1P.
it's just P.
What is negative 8 plus 1?
-7.
Minus 7. Okay, over P minus 4. Can we do anything on the top, or is it prime?
It's prime.
It's prime, so we leave it. Done.
Yeah.
If it's not prime, don't forget to do Xbox on it again, right? But if it is prime, leave it, and that's all we have. Okay? Any question on that one? Oh, just for fun, what's the excluded value here? Or, right. Okay, that's number 6 for you. Okay, so moving on to 7. Complicated? Yes. Why?
It's not. No, it's not.
We realize something. This is a fraction divided by a
Fraction.
fraction.
Oh, I thought it was just numbers on top of numbers.
See it? So you gotta look at it that way. Now, let's start with the very top. X plus 5 is already simplified.
Yes.
Done. What about this one right here? What do we do?
We got Xbox.
Let's X box, or just X in this case, because it's a 1 in front.
Yes.
So negative 8 on top and 2 in the bottom, right?
Yeah.
What times was negative 8 added to 2?
4 2.
4 and 2, you said?
Yep, but
Negative
the
4.
2's got to be negative.
Oh.
Ah, very good.
There we go.
Nice. Okay,
First time.
while we're at it, let's do the same thing for the bottom. On the top here, what do we have?
Negative 2.
Negative 15 and 2. What times what?
5 and negative 3.
3 5.
5 and negative 3, okay?
Ooh.
And down here, what do we have?
6 and negative 5.
What times what is 6 added to negative 5?
Negative 2, negative 3.
Good. Now let's put the whole thing together.
Yeah.
Okay. So on the top we have x plus 5. I put parentheses around it for a reason because it's already simplified. Over x plus 4, x minus 2. Watch what happened next. Instead of writing it as a division, I realized that, hey, when we're dividing fraction, we know we have to do what?
Flip.
Flip the
Second.
second fraction, right at the bottom. So that means this one will go on top, and the 5 and 3 will go on the bottom, right? So watch what happens when I write it. I have x minus 2, x minus 3 going on the top because it used to be the bottom, and the top now will go down to the bottom, which is x plus 5, x minus 3. So this is a very crucial step. Every time you involve division problems such as this, don't forget to times it by its reciprocal. And now we insert our cancellation process because we know everything's already linked up by a multiplication sign.
Yes.
What can we cancel out?
X minus 3.
X minus 3 is gone.
X minus 2.
X minus 2 is gone.
Yeah.
X plus 5 is gone. What's left over?
1 over X plus 4.
That's it. And that's
I
it.
told you I got the answer.
Okay, that's number 7 for you. Any question on this? I hope it's good. I mean, right, most of them, right. But notice that every time you see 1 here, you should be happy because we don't need to do a box for it. Okay? Here's number 8. It's now an equation. And notice that I changed the way I asked you to do it too. I didn't ask you to simplify, I asked you to solve. solving means I know I'm going to have a variable equals to some value. It's an equation, and we have fraction involved. Every time we have fraction involving equation involving fraction, what do we want to do? Equation involving fractions. What do we want to do?
Get rid of them.
Get rid of fractions, right? If we want to get rid of fraction, we have to find what? LCD. So, this is not completely factor. Can someone help me factor this thing?
Xbox 6
Okay.
and -6, 1. What's it called? 5, no, 6.
3,
Wait,
2.
3 and 2.
3 and 2.
3 and 2. So if I write this out, let me go ahead and cross it out now. It's simply going to be x plus 3, x minus 2, right?
Yes.
And there it is. Okay, let's observe again. Remember when we find LCD, we do 2 fractions at a time? So let's take a look at the first 2. What is the LCD for this and this?
X minus 2.
Or you basically what you're saying is just a product of both because they are.
product of both.
Okay. Now, if the LCD on this side is x minus 2 times x plus 3, and you look here and compare, like they're exactly the same, so what is the LCD for all of them?
X plus 3, X plus
The same.
Yeah, that.
So that means we can just basically multiply everything by what?
X plus 3, X.
Right. You multiply everything by its own LCD. And remember, when we say multiplying, we are really cross-canceling first before we multiply, right? So let's start doing this. Over here, what can we cross out?
X minus 2.
And what do we multiply to the top?
X plus 3.
X plus 3. So for this fraction, it will now be this. Next one, what can we cross out for this fraction? X plus 3 will get crossed out. What do we multiply that to the top? X minus 2, okay? So this is what I have. Equals, of course, everything gets canceled out, so there's nothing go to the top. 5 remains as is. And now, notice my fraction equation, now clear fraction. Okay? And remember, we want to break free the x, right? This one's easy because how do we break this x out?
Distribute.
Distribute. Over here, however, what do we need to do to break this out? Box it. See it? So depending on the situation. Here, we box this. We have x minus 1, x plus 3. Let's multiply it in here. This is negative x, 3x, and negative 3. Combined like terms. So let's write it out for you. I have x squared plus 2x minus 3. Here you distribute to break out the x inside. You have negative 7x plus 14. And watch what I'm doing next. Where did I get this from? Where did I get the negative 5 from?
You subtract 5.
Why did I move the 5 over?
Zero.
Oh, zero product property. Every time we have an equation, we want to have that 0 on one side. And that's why, because I'm using z to p, zero product property. Okay? And so, let's put the whole thing together, see if we have any like terms, and we realize that we have quite a few. See that? All the circles and all the boxes? Let's combine them. Here's the x squared. What is that? 2x minus 7x. What's 2x minus 7x? Yeah, what is that? Negative 5x. What is negative 3 plus 14?
No, it's positive 11.
Positive 11 minus 5.
6.
6. So plus 6 equal to 0. Can we do an x on this?
Yes.
What is that going to get us? 6 and negative 5, so what?
3 and 2.
3 and 2, but then that will give us negative 5 when we add. They're both negative. Very good.
Yeah.
So if they're both negative, my factors will look like this. X minus 3 times x minus 2 equals to 0. How many cases do we have here?
2.
2. So that means I can break them and solve for 0, but because this is a simple version, I know that x is either a 3 or a 2. But don't be happy yet, because if you read the direction carefully, it says this. State any extraneous solutions. Extraneous solution kind of goes side by side with excluded value, meaning you look at the bottom, test it out to see if it's going to make it 0 for the bottom. Let's test out the 2. 2 goes in here, whoops, that would go with 0. So we cannot have that. So that right there is extraneous. Okay? What about the 3? Well, that won't go to 0. That won't go to 0. That won't ever go to 0. So the 3 is safe, right? Therefore, 3 is your real solution and 2 is your extraneous solution. Yeah. So that's how you verify. So extraneous is the same thing like excluded value. Excluded value, we use it when we have just a regular expression. Extraneous when we have an equation. So that's the main difference. Any question on number 8? Okay. I hope you like this next problem. This one right here involving work.
Oh, I did that.
This is actually pretty easy to set up, I hope.
I'll
But-
leave you.
We have James and we have Sally, right? And James, how long does it take you to wash a car or to clean the car? So one car, one task,
Over 20.
20 minutes. Sally? 1:15. And together, we want to find out how long it would take them, right? So we don't know how long. Don't forget that we always declare the variable ahead of time. I know I'm trying to skip that step, but we always declare that x means what? The time will take them to what? Okay, now here's the thing. Some people put a 1 on top. Does that mean it's wrong?
No.
No. It means that you just try to find the time to wash just one car. Whatever time you get, at the end, what do? Multiply with 15. Or if you don't want to do it, you just put 15 up here. It will take care of itself. That means how long will it take them to wash
No.
15 cars? Yes.
Is it possible to cancel out the 2 15s?
No. Cannot do that. You know why? Remember, the only time you can cancel out top and bottom is when they're linked by what? What is this here? That's an equal sign.
Two
You
lines.
cannot do that, right? Okay, so don't even try to do something like that, ever. But we can certainly find an LCD.
5.
60.
60. What? X.
Then multiply it and yeah.
Cancel first before you multiply, remember? We want to
3x
make
plus
sense.
4x equals
60x divided by 20?
3x.
3x times 1?
4x.
Whoa.
No, it'll be 3x plus 4x.
Yes. And what is
900.
900?
Oh, that's a big number.
Okay, yeah, this is the reason why some people put this as a 1 right here. So it will remain as 60. You solve for it, you times by 15, up to you. Okay, doesn't matter. But here, this becomes 7x equals to
900.
900, and you divide it carefully enough. X is approximately 128 minutes.
I got 192.
She's 1 minute off.
Oh, we got 29.
Or around there
Yeah,
somewhere.
we got 129.
Or maybe you rounded it, right? Around. Okay. But at least it takes them at least 2 hours or more to complete all 15 cars. Question on that? I hope that when you see a word problem next time, you don't get panicked or anything, because that's how we set up. Same exact structures, whether the X goes in or out, right? We still have someone working with someone, or we can have like 3 or 4 people working the same. Doesn't matter. I mean, we have several fractions, 1 fraction for each person or each party.
I would feel more comfortable if you put that as 129.
Okay. Whatever. If it means that much to you, Santino, I'll do it for you.
Okay, go.
There
Do it.
There
Oh,
we
you
go.
did it.
There we go.
Okay, happy now?
Yeah.
Yes.
Okay, fine. Yeah, there's a fractional part to it. There's a decimal part that you can certainly round. All right, moving on.
And he erased it.
Last one.
Do it again.
Tomorrow, if you want to ask more about the dimensional analysis, please feel free to ask. But this problem is a demonstration of that. I'm basically asking you to convert miles per hour to feet per second. Okay? Miles per hour to feet per second. The trick to have a successful case of dimensional analysis is by having everything linked up by multiplication. That's the first thing. The units are always in opposite positions. I mean, one has to be on top, the other one has to be at the bottom for you to cancel out. Just like what we've been doing all along. Okay? So look carefully enough right here. This is a multiplication problem. That's easy. Division. How do we change this to a... So if we turn this back into multiplications, we flip, right? Okay, so let's rewrite the problems. We have 20 miles over 1 hour times it by 5,280 feet for 1 mile times it by, look what happened, 1 hour over 60 minutes, and we have, once again, another division problem. So we turn it back into a multiplication and we flip. So it's 1 minute over 60 seconds. That's fine. That's fine.
Okay.
Because technically speaking, whether you have this or not, can we still multiply back in? Like distribute? So no, it's not distribute. It's the same thing. Because whether I write it like this, is that still the same thing as A times B times C?
Yes.
That's why we don't care whether it has brackets or not, or parentheses.
Okay.
Okay. Now, Watch what happens. Here's the part that you need to be careful about. Let's see what units we can cancel out. Look, hour on bottom, that means we expect to have it on top, right? Do we have it on top?
Yeah.
There it is, gone.
Sheesh.
We have
Minute.
minute
Yeah.
and minute, gone.
Right there.
We have miles and mile gone.
Feet.
So now we end up with just feet over second. So let's do it. Here's the thing that I don't want you to do when you work on this problem. Do not take 20 times 5,280.
No.
I'll make it bigger. Instead, write it out. 20 times 5,280 over 60 times 60, right? Are they all linked up by multiplications?
Yeah.
That means we can cancel out something. Look at 20, 60.
3.
3.
Okay,
One and
where?
three, one and
2.
Top.
Wait. Where's the 3 going to be?
At the
three.
top.
The bottom.
The top.
Bottom.
Wait. 20 divided by 60, you tell me it's going to be...
Oh.
You see it? You see it?
Okay.
Think of how we cancel out terms. The one that's more going to take the lead. So in this case, the 3 will be in the bottom, right? See it? And here,
This one.
at least if at this point in time you want to cancel some more, what can we cancel out here at least?
88. Oh.
Oh,
0.
by 10, right? Because they
Zero.
end both ends in 0. So if you do it, if we do it by 10, it's going to be 528 over 18, right? Because now it's going to be gone. Is that true?
Yeah.
So we can now divide. 18 outside, 528 inside. 18 goes into 52 how many times?
3, 4. I don't know. That's got the answer.
By 2? Okay. So that's 16 and 3, right? Subtracted, 12 minus 6 is 6, 1, right? Bring down to 8. 18 goes into 168. Is it 9 times? Okay, let's do that. 9 times 8 is, what is it? 162? Subtract it, you get 6, right? So that means 29, 6 over 18, we can reduce that to
3.
1/3.
Yes.
So that means our final answer is 29 1/3 feet per second. There it is. And that's how we do it. Done, guys. That's it.
Oh, that's an